Alright guys, welcome back. So in this lesson, you guys need the knowledge of creating templates and some object-oriented program review. And also the ADT, abstract data types. So you're going to learn about those things before we delve into linear structures lesson. Okay, so this lesson is really important in regards to review of OOP and learning new stuff in regards to function templates and also abstract data types. So here's my promise today. So I'll use an example to demonstrate abstract data types. Function template. Okay. So and also um, I'll demo an OP via an example. Okay. And I'll also demonstrate how to overload an operator in C++, which is really um, important task on creating our own classes and objects. Okay, and then I will demonstrate how to do a class template. So we first do a function template and then class template, and then I will go over abstract data type ADT using an example. Okay, and then now I'll demonstrate how uh, C++ inheritance work using same example, and and then at the end I'll demonstrate how to do C++ composition using an example. So let's start. All right. So um, we usually say don't repeat yourself in program, right? So yet we rely on functions working with specific types so far. Okay. So so in reality though, right, many algorithm works with several data types. Okay. So for example, we can sort an array of ints, we can sort doubles, we can sort strings. Okay, so all right, so we know that our selection sort worked with integers, only integers. So let's take a quick look on that. Okay, so what I'm going to do is I'm going to jump to our selection sort. Okay, so it's our code base and this is our selection sort, and we see that this will run. Okay, all right, so in fact I can run and then show you guys, and then we have a vector of doubles. Okay, and that we're gonna try now. Okay, so I'm gonna unblock this and show that, and we'll see that this wouldn't work. See that it's saying, all right, no matching function for call to selection sort, because I'm trying to feed uh, a vector of doubles, but our selection sort only work with vector of integers. Okay, so that's the reason. Okay, so it's vector of integers. So this is not designed to our selection sort. This is not designed to work with vector of doubles. Only work with vector of integers. That means th- this means our code doesn't work. Okay. All right, guys. I want to apologize for the background noise. I am actually away from home. That's why. Okay. So I'm going to block this code, and then we go back to our lesson. Okay. All right. All right. Okay. So we just so that our selection, so the general code that we wrote, the initial code that we wrote didn't doesn't work with only work with integers. Okay. So we can solve this problem using templates. Okay. So that means basically you can take out the type dependence of your code by writing templates. and then I'm going to show you how. Okay. All right, and then we perhaps so far use template codes actually, right? For example, but we didn't write our own functions or classes. So in this lesson, we're going to learn first how to write our own template functions and then class templates. Okay. All right. So we know that type parameter. So in templates, type parameter take care of type dependence. Okay. So basically, what we do is we pass the type as type parameter. Okay. So it can be one type or many. Okay. So then basically at compile time, we select. So at this time of the usage of our function or the class, we can specify which type we want to use in our template. So that's the idea. Okay. So that means we're going to pass the type, real type that we want to use in our function template at the time of the compilation, at the time of the usage. Okay. Perhaps mainly in the main program usually. Okay. All right. For example, we did already when we creating an std array, right? When we are creating an std array, we already did this. Like for example, here std arrays, it takes the type as the integer int, and then it takes another non-type parameter for the length, and basically that's what we did. Okay, so 10 here is the non-type parameter. Okay. We already used that. So the actual type, like I said earlier, actual type is realized at compile time. So we call this sometimes, we also call this compile time type safety. All right. So don't get confused. This is still not dynamic typing. Okay. C++ still is a statically typed language. Okay. All right. It's not a dynamically typed language like JavaScript. Okay. All right. So one thing you need to understand is that template is not a real function. Okay, so very important that you understand this. I also linked the resource as well. So it's not a real function or a class. If it is a class template, not a class. At the time of compilation, compiler generates the actual code or actual function or actual class. So it's just the template, and compiler will generate a separate actual function depending on the realized type at the time of the usage. Okay. All right. So this means basically compiler must see all code in one place. Okay. So like in a separate class, you cannot separate the class definition and the code separate. You have to have everything in one place. Right? So you cannot separate declaration and definition. That's for even for the function or class, both it's the same. You cannot separate the declaration and the definition. Okay. So it's the syntax for writing a template function. Okay. So we start it with the keyword template and then class and then T. We use this sort of standard. T means template. Okay. Or a type. Okay, and then if we have more, then s. Okay, so we can pass more types. So let's say for example if we have two types, then s. Okay, so then int, this is the non-type parameter int. Okay, so it's a not type parameter, it's a just a number of type int. Okay, we call it non-type parameter. So this is just a syntax. Okay, and then in this separate syntax, it returns the type s variable. Okay, so and then we pass our parameters. First parameter in type T, and then the second parameter is in type 2. Okay, and we do something, and then it should return something with type S. So return something of type S. All right. All right, so let's go check our example on writing template. So I have written my code already. Okay, so I'm gonna go to library edge. Okay, so to save time, I have written the complete code at the very beginning so that we can save time. So I'm going to explain those lines of code. Okay, so we already have, so this in the selection sort, see that we separated the definition and the declaration, but in the template we have to have all the code in one place. Okay, so that's why I have the entire function definition or template definition over here. Okay, so it does start with template, and then I only have one type of variable, which is either double or integer, whatever the type, and then the uh, name of the function, and then I am going to create vector of type t, which I'm going to pass. All right, and then the code. Okay, so it's this code, basically same code that we have in or earlier we had four selections. So okay, so I have that code here. Okay, so it's the same code. All right, just for the uh, type t. Okay, so for the vector that we pass over here. Okay, right. So that's it. And then basically we go to the main program. Okay, and we saw that this didn't work. So now I'm going to use the the function, the type independent function over here, the template code over here for this double vector. Okay, so we are creating that double vector over here. It's a random double vector. So this one, I'm going to pass that and then sort it. Okay, so before that, I'm going to print it before sort, and that's this code. And then I'm going to sort it, and then I'm going to print after sort to prove that it's actually working. Okay, so and then in this code, what I'm going to do is I'm going to create a string vector of strings. So I took this Thomas Edison's code, and then I basically broke that string into words, basically separated by space, and then I populated the vectors. So it's a string vector there, and then I again print before sort it, and then apply the generic selection. So now with the string of okay vector of strings. Okay, see see the utility of the type independent code. I didn't have to write this again for string vector. I am using the same code I when I write the template. Okay, same same for the double. Okay, and then after sort. So in sorting a string characters, C++ use um, a lexical uh, ordering. So we'll see that according to that ordering, our words gonna get sorted. Okay. So let's run this program. It's gonna run the entire program. Don't worry. I'm going to explain everything in the program. Okay. So 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 let's see what we get. Okay. All right. Here we go. Okay. All right. So first it was integer um, vector, and after sort. So this is a random vector, random vector of integers, and after sort we have this. We can see that it's sorted, and then it was a random vector of doubles, floating point numbers. So we have had these, and after sort we have sorted array of numbers, and then it's a string of vector of strings. So before sort, it's actually broken into words that phrase from Thomas Edison, right? And then after um, sort, okay? So after sort, we have ordered words according to lexical ordering, okay? Lexicographical ordering, okay? So because big M has the lowest value in the lexical ordering, so this many comes first, and then likewise, okay? All right, so that's that. Let's go back to our lesson. All right. So we go over here. Okay. So I'm not going to go over each slide of software objects. Okay. So I highly recommend to run the slideshow and then try to understand, simply because to save time, and then you should have done this in your 110B class. That's why. So you should run the PowerPoint and basically uh, try to understand the slides, and then um, you know do the review, right? So I'm not going to go over each slide. I'm going to directly jump into um, this code. Okay. All right all right so the problem we had with the uh, we know that we wrote maybe I can just show the first slide. Maybe I can. All right, so remember we solved this problem calculating grades and class averages. But one thing we couldn't do is to do this for each student, right? So we just pick some class, calculate class average total, and then create calculate the grade. But we fail to attach the student to its own student's own uh, class average total. So that's why functional programming failing to attach the data into get the notion of the object into the code. Okay, so OOP solve that problem. So we're gonna see that in this example. Okay, so I'm going to directly go into that code. Okay, so that's actually student. So let me just go over the problem, and then I'll explain a way to uh, design also. So we need to remember we need to do the umpire process for the class design as well. I'll explain. I'll introduce you a way to do that as well. Okay. So the problem is this. Okay, write a C++ class to represent a student in this course. Okay. So we already did that for not a class. We actually wrote a function to represent to calculate the class grades basically. So now we're going to basically do it for a student. So basically we are going to write a student class. Okay. So student has a name, an ID. So it's initially an integer. Okay. And the average class total. Okay. So then basically we have to do is follow the umpire process in the class design. So I'll show you how to. Okay. Write the constructor. Okay. So basically constructor is basically when a student enroll, you create a student. Okay, so it's basically can consider that as the enrollment of the course to the course. Okay, so write all getters and setters and facilitate the calculation of letter grades. We already did that function. Functionally we're going to do it in the object-oriented sense also. Then basically design an implicit way of counting numbers, number of students as they enroll. Okay, so we're going to do that as well. Then we're going to create a vector of students and then sort. So this is really important. How do we sort our own object that we create? So I'm going to show you how. And then ID, I said it's here is an integer. It can be a string too, and we have to make our code basically to work with string IDs as well. So that means we'll have to write a student class template. So that means I'm going to show you here how to write a class template. Okay. So let's go for the design process. How do we design this class? Okay. So here I have written this XLS spreadsheet file. Okay. So one thing we have to do is basically we need to find first the names involved in our problem. So this right here, the names involved with the problem. So that means we have to figure out what are the subjects in our problem statement. Okay. Obviously, first choice is student, right? So the student, we are going to write the class student. Okay. And then other names are basically right. So one thing is student, and then and student has a name and an ID, okay, and the average class total. Okay, so those three things we have to write as well. So name, ID, class average total. Okay, so that's what I have the variable name. Then you have to write an association between these names. Okay, and then one thing to note that we are being asked to write the student class. So that means it's better to write the association between the rest of the names and the student. Okay, so that's why I wrote over here student has a name. Okay, student has a name, student has an ID, student has a class average total. So I'm going to basically repeat the same over here. Okay, and then these are basically then the type. So these are basically seems like the data belong to the student, right? So they actually they are members, right? So we can actually repeat. So I have just one completed for the student name. So I'm going to complete it for the rest, right? So this is actually members, okay? And then you have to write. So these are the type. So what kind of member or thing? So here it's a student, okay? The class, and these are actually members. So that's the type. Don't get confused with the actual type involved. Okay, so this is just the whether it's a distinction between class or a member type separation. All right. Here, so then we can write the actions involved with the name. Okay. So if we have getters and data setters, and then basically get name and set name, you can do that, right? Sometimes you will have to make a you have to use your domain knowledge to uh, make a decision here. Like sometimes some may argue, okay, so what kind of how do we make sense of setting a name, like changing names later? And one can say, yeah, anyone can change their name legally. So the calculate grade, and this is what we have written earlier in the class. Okay, so I simply copy pasted that code, but it's student calculate grades. Now you can see that, right? See that we nicely attach the function or the action of calculating grade to a student, particular student. So that's the idea of object-oriented programming, right? So we are no longer just calculating some students' uh, average class total, sorry, grade. We have a attachment to the student. Okay, so that's the idea of OOP. All right. So let's go back to our result. Okay, so I'm gonna go over here. So we created the So right here, it's right here. Okay. See that after first student, Jason, the number is 1, and then I created 2 more, and the number is 3. Okay. So then basically we go back to main code. Okay. And basically so I'm printing that. So that's basically right here. It's number 3, and then I actually uh, printed the get name. So it's basically okay. So Kate has this grade. So it's calculated the grade, and we got C. Okay. Then I set the so basically okay. So some reason Kate's average total was wrong, so we actually set it to a new value. Now the grades is A. So it's the verification of that. Then I basically, for some reason, let's say Kate withdrew from the class, so I deleted. So this explicit call to a destructor. So now we verify, and the total number of students created. So it's now 1 less than. So it's here 3 with Kate. Now that Kate has gone, we have 2. Okay. All right. So the next basically, um, so in the let me go back to the problem statement. We have this, right? So we have this table. So we're going to create a we have this data. Okay. So we're going to create an array of students. Okay. So that's what we are going to do here. Okay. So right here I have the array of names. Okay. Array of IDs, the same columns that we have in the problem statement, and the array of student average class total. Okay. So basically, then we can create basically a vector of students. See that? So type is student. It's our own type. So we're going to create a vector of students objects. Okay. So that um, vector is students, and basically in this code we basically push each student. So we are creating a student, right? So it's really cool thing that we can do such kind of things, right? So in an array, right? So in a for loop, we iterate the constructor and pass each name and each ID and each total and create a student object, and then we push it into the vector. Okay. All right. So it's not a vector of strings. It should be extra of students. Okay. Sorry about that. All right. Okay. So, and then the idea is this. We want to sort this vector. Imagine that, okay, so we have a vector of student. Now we have to sort it. So the problem is this. So there's no concept of sorting student. Right? There is a concept of sorting, let's say, like student average class total, right? It's a real number. You can actually sort it to find which one is the highest or which one is the lowest, or simply arrange them in ascending order. But there's no way to order student objects because that concept of sorting a student is not defined, right? We don't know what should be the criteria of sorting bunch of students. It could be the name, it could be the ID, it could be the student average class total, it could be even the grades, but we have to define it. So to do that, we need to actually overload the one of the comparison operators, basically this one. Okay, we need to overload this operator. Okay, we have to say, so basically when we compare things, let's say in a programming language, the primitive variable, it's defined. We use the one of this comparison relational operator in comparing um, objects when we sort. So it's a comparison based sort, right? So we have to compare. So that means we use this operator when comparing. So that means basically we have to define our this scenario, the comparison of two students, right? So this is we pass the other student as a parameter, and then we have the current student, so we compare, but we have to define this operator. What should be the criteria to compare two students? Okay, so basically, I said in the problem statement that should be right. Sort this vector based on the total, so basically class total, and verify the sorting. Okay, so that means we have to basically use the average class total to compare two students. Okay, I mean it's just there's no such standard. We are uh, doing it specifically for this class. Okay, so let me go to the code for student, and this is the implementation of the operator. So we call this kind of way of defining our own operator for existing operator called operator overloading. Okay, so overloading operator for our purpose. Right? In this case, so if this current students average class total is less than the other student that we are going to compare, and then we return true, otherwise we return false. So it's a boolean function, obviously, right? Less than, greater than, those operators return boolean. So it's return boolean, but here is the criteria. Okay, so we call this kind of way of redefining an existing operator is overloading, operator overloading. And then C++ allow almost all, except there are several like I think very few operators that you cannot overload. I think you cannot overload this operator, the scope resolution. Um, there's a couple more, I think. Anything else you can actually overload, including like the array index operator, the pointer operator, those stuff as well. Okay, so so what we are going to do is now we have an array, sorry, um, vector of students right here, and we're gonna sort it. So before that, we're gonna sort before we're gonna print them before sort, and then we sort them using sort method, sort function in standard C++. So we have algorithm library imported, so we use that. Okay, and then we're gonna print. Okay, and we'll see that. So let's see the result. Okay, so before sort it's Ruth, Martin, Helen, Mary, and Ben. Let's see that we can verify that, right? Ruth, Martin, Helen, Mari, and Ben, and then it's after sort Ruth first, Ben, Mari, Martin, and Helen. And see that it makes sense. So Ruth has the lowest, and then Mari, and then Martin, Helen. Sorry, it's Ruth, and then Ben. I think that's the way it should be, right? So Ruth and Ben. Okay, then Mari, Martin, and Helen. So let's see that. Mari is next, and then Martin next, and Helen is has the most. Okay, so that means basically our function did work the way we really expected. Okay, so notice when Ruth and Ben both has same, right? So that means we first have Ruth, and then then we have Ben. So we call it the relative ordering. Okay, so the relative ordering is basically when the 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 sorting concept, the two values are same, then the sorting mechanism should preserve the relative ordering. So what is the relative ordering here? Ruth should come before Ben because simply Ben is sitting behind Ruth in the array. So even though their totals are same, Ben is sitting at last, like after Ruth. So when we sort, Ben should come after Ruth. We call it relative ordering. So select and sort preserve the relative ordering. Okay. So not selection sort in this. Sorry, I take it back. In this case, the C++ sort mechanism preserve the relative ordering. That's what it means. Okay. So right, we have root first and then second, but they both have similar uh, class order. Okay. So it works. So earlier, if we try to sort without, so let me try to do that actually. So if we take out these two functions, we try to sort. Let me just take out these two definitions and then here also. Okay, all right, and go to main program and see that. Try to see the code. Okay, so let's try to run this code. Should get an error. Okay, see the error. So no match for operator less than for this type. Okay, so basically sort require that operator defined for students, but it's not there. So we get this runtime error. Okay, so what we did was actually we actually wrote that uh, mechanism by overloading that operator. So let me just unblock this also. I can rerun, get the same result. Okay. All right. So the next, yeah, so it ran properly. Okay. So let's go back to our lesson. The next one is um, inheritance. Okay. Again, guys, I'm not going to go over the slides to save time. So you guys need to uh, I highly recommend going over this and then reviewing your inheritance knowledge that you did in 110B. All right. So it's gonna go over to we're gonna jump to this classes and abstraction. Yeah. Okay. So I'm gonna go over from here. Okay. All right. So we know that in reality we use names to identify object, right? So if you take a microwave as an example, okay, and we know that by its name it can cook, okay, right? So, but we don't need to know how it warm or cook, right? We don't care about it, how it does it. We only care what it does. In this case, warm or cook, as well, right? For the microwave. So for most of the lay user, we don't care how it works. Okay. So we simply trust that it can do it thing. Okay. So basically, in real world, we use the name microwave to define a set of complex behaviors and respective data, and then we basically give that name microwave so that we can represent those behaviors and then data together with that name. Okay. So basically we know how to use any microwave because this concept underlined by the name microwave is well defined in the society. So we don't worry about how it works or specifics. We simply refer the name microwave. Okay. So dealing complexity this way is called abstraction. Okay. So the name for this kind of dealing is called abstraction. We say we abstract out the things it does and all the data and the behavior into its name. Okay. All right. So in CS, basically we use abstract data types to implement abstraction. Okay. Okay. So abstraction is very common in reality. Okay. So usually, basically, only makers of an object worry how it works. The users or the society basically simply use it by that name. Okay. So basically, they have a trust that it does what it's supposed to do. So we have that trust. So the usually general society don't worry about how it works. Okay. So software objects also works the same, right? So bunch of engineers design a library, okay, or complex classes or libraries, and then bunch of others or many others use it, right? So um, and then basically, how do you do it? Basically, they implement it and then cover up that whole the design by a name, right? So they give it a name, usually a class or a library name. Okay. So, and usually others trust it. And if they don't, then we go back to the design again and redo it, right? So that's what we could do it in software versioning, right? So with improving code means we go back to the drawing board and then redesign or improve a class or a library, right? Okay. So abstraction, then there's a definition for abstraction, simply managing complexity by labeling a set of behaviors and associated data into a single name. Okay. So for example, um, string class in C++, right? So we know that strings are text data, and we know that there's a bunch of operations associated with it. So we put them together and then we call it string class, and it's available to other engineers to work on. So other engineers don't care how the string class has been implemented. We simply use it. Okay? That's the idea of abstraction. All right, so then let's talk about what is an abstract data type in C++. Okay, so an ADT help us to implement abstraction. Okay, so the way we do is basically there are two things involved for a data type. So data type has a logical form and a physical form. Okay. So if we try to implement both, so that means we have the both the logical form and then the physical form are together. Now they are intertwined really tightly. So that's going to cause um, that's going to basically hinder the development. Okay, so we need to separate the two. Okay, so an ADT basically specify how this logical form um, through an ADT. So we use an ADT to specify the logical form, and the respective data structure implement the physical form. Okay, so we say basically ADT provides the interface so data structure can implement it. That's what we say. So abstract data type provides the interface so that the data structure can implement it. All right. So, so basically, then the ADT, the definition of an ADT is basically the specification of a data type within some language independent of an implementation by defining the type and the set of operation on that type. Okay. So, for example, if we take the microwave example, right? So it has the front interface with the options to cook or to warm and time, all those stuff, right? So those are the functions and the logical representation. And then many manufacturers follow that concept and do their own thing to make microwaves. That's the physical implementation. Okay. All right. So the logical implementation is the concept of the microwave. Physical implementation is the actual product. Okay. So same idea works here with an abstract data type. So logical interpretation is what it does in um, uh, in set of operations and associated data, and the physical implementation is actual implementation inside. Okay. All right. So then let's talk about how do we specify an ADT and how do we implement it. Okay. So many languages, many object-oriented languages facilitate this in a variety of ways. So I'm going to talk about both Java and C++. Okay. So in Java, we use interfaces and abstract base classes to specify ADT. Interfaces or abstract base classes to specify an ADT. Okay. So basically, we can either use either implement, right? So we use implementation of an interface, or we can use the inheritance, and then we can create a concrete class out of the abstract class. Okay. So Java allows two ways of implementing an interface. One is we can directly implement the interface if it's an interface. If it's an abstract class, then we can use inheritance and create a concrete derived class out of the concrete base, abstract base class to implement it. In C++, there's only one way. Basically, we can create an abstract base class to specify the ADT, the logical implementation. For the physical, uh, to implement basically, we can use the inheritance and concrete class to implement the ADT. So we have the base class, abstract base class. We create a derived class, a child class out of that class. That means we use inheritance to create a concrete class to implement the ADT. Okay, so that's basically the physical implementation of the ADT goes into the concrete class. The logical implementation stays in the abstract base class. Okay. All right. So in general, in public, ADT also calls application programming interface (API). Okay, especially with the web's development, web application development. This is a really common name that we use um, in development, API programming. Okay, so we basically say we write an API. That's actually say we are writing an ADT. Mostly, um, usually in JavaScript on the client side, in the backend side, there are a variety of languages, including C++ and Java and PHP and uh, also including JavaScript too. Okay, all right. All right, so let's um, use this problem to both learn how to use inheritance and also to write an ADT. Okay, so the problem is this. Okay, write a simple C++ ADT abstract data type, excuse me, to represent a triangle. So why we need that ADT to represent triangle is that basically to represent a triangle there are multiple ways. I think there are like 6, 7, maybe even 8 ways of uniquely specifying a triangle. So we're going to use two of those ways here in this problem, but there are multiple ways. So then you can ask question, why not facilitating all of those ways of implementing a triangle um, to any of who has the interest to write a class to represent triangle. So that's the idea of writing the ADT. Okay, so we're going to keep things simple by only focusing on two ways of creating triangle. Let's read the problem. Okay, a triangle has operations to calculate the area. So these are the operations, the logical operations, area T and the perimeter S. There are multiple ways of representing a triangle. One way of representing a triangle is through its height, H, and base, D, and one angle at either side of the height. Okay, so um, right, and then I think we have the picture over here. So this is that. Okay, so we have the height and the base D, and then I'm talking about this angle. Okay, so then if we when we have this data, this is a unique triangle now, then we can basically write each sides in terms of using trigonometry basically. So AB is D, the base, and AC it's divided by sine A, this side, and CA. You can try this out by using your own trigonometry knowledge. This is the formula for that. So for BC, okay, and the T is the area. It's basically the height times the base divided by 2, and the perimeter is basically simply the sum of those all three sides, so AB plus BC plus CA. All right, so another way of representing a triangle is through all the sides. Okay, so that's that. This is that option. So we have ABC triangle, and this is the way of this the standard way of marking a triangle, right? So the side in front of the angle A has the length A. So A angle is big A. The side is the side in front of which is BC has the length A, and the angle B has B, and then the side in front AC has length B. Likewise, so this is the standard way of representing a triangle. So if we follow that way of um, like having all three sides, then T is the area is given by this formula. We call this Heron's formula. Okay, I can actually show it to you over here. Yeah, so this is the Heron's formula. Okay, so you can simply Google triangle, and then you can go to wiki page and then scroll down to this. Okay, so this is the formula. Okay, that I had, and then and then the perimeter is again AB plus BC plus CA. So A plus B plus C. Okay. All right. So, um, so what we have to do, and then we have to do specify the triangle ADT, namely triangle ADT, and implement both ways of representing a triangle by implementing triangle ADT. Okay, so we have to uh, so we have the ADT, and we have to write two classes to represent each way of doing the implementing the ADT. Okay, and then create two triangles using both. Okay, all right, so let's go back to coding. So I've already done the coding, so I'm going to show you because to save time again. So this is the triangle ADT. Okay, okay. Excuse me. Okay, so um, So list ADT. So it's a well, again, it's a template. The reason why I think it's in this problem statement as well. If I haven't put it. Oops. Okay. So yeah, let's see. Yeah, I think I again to show you guys, okay, you can do it as a template as well because side, oh yeah, so sides can be either real values like double floating point numbers, or they can be, if it is in a graphical user interface, then it could be from pixels as well. So that's why we want to we need type independent code. So that's why I have chosen to write a type independent, like templates ADT. Okay, and then in fact our in our list lesson we're going to use um, template ADT. So it's good to have that experience also covered here as well. Okay, that's why. So it's a class triangle ADT. So this is the abstract data type. It's not list ADT. Sorry, I probably have copied that over here. The triangle ADT. Okay. All right. So and then there's a default constructor, and then virtual base virtual destructor, and then whenever you write a whenever you write a abstract data type, consider writing this so that you can use you can actually create derived classes or child classes out of this without um, uh, leaking memory. Create and delete, use child classes without losing or without leaking memory. So you need to have virtual destructor defined. Okay, and the two operations. This we said in the problem statement. There are two operations with triangles. One is calculate area, the other one is calculate perimeter, and these are virtual methods. That means this how pure virtual. So we say these are pure virtual functions in C++. Whenever we write, we use the virtual keyword and then make this specific construct, and we say this is a pure virtual function. And whenever a class has a virtual function, we say that class become an abstract class. So this is an abstract class. Okay. So in this ADT, we have two operations. One is calculate area, the other one is calculate perimeter. Both has type E. Okay, so this is pixel going to come it as integers, right? So pixel doesn't have fraction values; they are whole numbers, so it's integer. If that's a real triangle with floating point numbers, then sides, then this could be double, okay, or float. All right, so let's go to the implementation. So one way of implementation is base and the height way of implementation. So that's that. So we need the math module here, and again it's a template. Okay, and it's a base class. So we use the base class, excuse me, triangle ADT base class, and now our this class become the concrete class. So we are going to define one way of representing a triangle completely here by um, defining those two functions that are missing in the ADT. Okay, so one is this calculate area. So we define that and we use this form, and calculate perimeter we use this form basically. Okay, so basically this is we find the AC side AC, and base is already a side plus AC, and then the rest the other side basically come with that the formulas in the problem statement. So I simply implemented that. All right, so that's one way of, so it's triangle 1 and triangle 2 is simply we have three sides. One thing I have, well, I'll explain it here actually, right? We know that just because we have three lengths for three sides doesn't mean there's a triangle possible, right? So we need to, there's a rule for triangle um, existence. We call it triangle inequality. I think we actually did that problem in the first, I believe in the first uh, programming assignment, right? So um, the largest side should be less than the sum of the rest of the two sides, right? So if not, we cannot draw a triangle out of those three sides. So we shouldn't be able to create a triangle, right? So that makes sense, right? So then we should handle that in the constructor because that's where we create triangles. So we should take care of checking whether the three sides would make a legitimate triangle. If it does, we create simply. Otherwise, we should throw an error to the user. Okay, so give me three more values. So this triangle is not possible. So we shouldn't create an object, triangle object. So that's how, this is how we actually handle these kind of scenarios. And this is really common scenario, right? Just because we have data doesn't mean we can create an object, right? So we should validate that. So this is a proper way of validating creation, object creation. Okay, so basically we can throw an error if the data doesn't make any sense or should not create an object. In this case, um, without breaking code, we throw this, okay, and we can handle it in our code in the main program. So I'll show you that as well. Actually, in fact, I have written that as well here also. So in this case, if either base length becomes 0 or less than 0, or height of the triangle become less than 0 equal to 0, means it's now a line. It's no longer a triangle, it's a simple line. So that means not a triangle, so we can actually throw an error at that point as well. So in the first implementation, this is how I handled that. Okay, and if that is not the case, we simply initialize and create the object. Remember, all this happen inside the constructor, right? Okay, so let's go back to our code. So this is the other one. So we calculate the area. Okay, so area calculation is actually Heron's formula here. Okay. And then and then um, um, here also the calculation of perimeter is simply a plus b plus c. Okay, and that's it. Let's go to main program and then check out our triangle ADT. So notice um, we use this notion, right, and throwing an exception if it's not a valid triangle. So we need to catch those. So we have to use try catch statement to catch those errors properly if we are not passing legitimate set of data to create triangles. Okay, so in here, so we are in this example, actually they are all legitimate, so we will create objects, but we can simply try excuse me, different data and see if that's possible. Okay, before that, I need to get the pi's value, so I'm calculating pi's value over here. So this math module doesn't have pi constant, unfortunately. I think in C++20 we have the pi constant, but we don't in this CMath module. We don't have it. So we can simply get that pi's value by taking the tan inverse 1 is angle 45, right? So angle 45 is pi by 4. So then we can get the phi by simply multiplying the tan inverse 1 by 4. Okay. So here, so I'm also going to explain one more really important concept called the polymorphism. Okay. Here you can see that I use the on the left hand, I use the uh, ADT class name on creating, right? Right. So we call this the declared type. And here I'm creating, so I'm creating using new operator, and on the right hand side, I use the actual side. So we call this actual type, declared type, the actual type. Okay, because I use the this triangle ADT as the base class, I can use that base class as the declared type. But on the right hand side, for the actual side, I cannot use this name because this is an abstract class. I can, we cannot use an abstract class to create object because, there's missing implementation in there. So there's no way a compiler can figure out that, right? So only these two guys did the implementation of those. So we have to use them in the right hand side. Okay. So so basically here I'm going to create one triangle with 10 height, 10 base and then 10 height, and then the angle is 60, right, in front of the height. Okay. So and then right here, let's see, and then if so we are trying that, it's a try catch statement. If that is not possible, then we have to catch the respective error and then output something. So even if this is not possible, this code still runs and then wouldn't crash, still runs. So that's the idea of using exceptions. You know, like uh, run safely running code without crashing a program, right? So that's the whole idea. So and here I'm creating all three sides are equal, so equilateral triangle, and then printing the area. So let's run this. It's already ran. So let's go over that. Um, let's see. Okay, so that's on top. Let's go to scroll up. Okay, so enter. Okay, so let's write. We have the area of T1. Okay, triangle one is this. The area of triangle two is this. Same, because actually right here I actually we have the same equilateral triangle. Okay, so one angle is 60, and then the height is 60 sine this much, so that when that happens, and the base is also 10, so this is also equilateral triangle of side 10. So here it's a direct, here it's indirect. So area should return one thing, right? So that's what I basically have over here. All right, and you can even so use both. In both actually I use double. Okay, you can use int as well, because if the lengths are in pixels, then it's integers. Okay, all right, so so that's that. And then we can one thing I wanted to show you guys is that actually we can now, so notice that it's a declared type is one, right? You can actually create a vector of this type, okay, and store different these subtypes as values. That's one way of let's say if you think you have several, if you want to use several, if you want to store several types in a single array, then you can actually uh, define an abstract data type that is common to all those data and create the declared type as triangle. Sorry, the that abstract data type, and store them in that array, because that's an array of that abstract data type. Okay. So for example, let me just try to store these two in this array as an example. So std array of, okay, what, basically triangle ADT, the data type, and there we have just two values, okay, and equals say um, tr array, and that equals, basically you can put those two values. Let's see what it is. Oh, std. Okay, there you go. Okay, so because I need to do it in the try statement inside, because this is the scope outside try statement. If I try to do that, the scope is um, different, so it has to be same scope within the try statement. Okay, but before that we define this array. Okay, and then t1, and the other one is right here inside one t2. Okay, right, so that's it. So, and notice now we have created an array of two types. One is in this type, one is in this type. So that's abstract data types. Actually ADTs enable that as well. So we call this, there's a name for this, we call this subtype polymorphism. Okay, so we use the subtype of this guy, subtype, and use it in the to define an array of two types. One is this, one is this type, the other one is this type, but the array is in as a whole in this type. So we can sort of provide a workaround to create an array with a variety of types. Okay. All right. So let's go back to our lesson. We have one more thing to cover, which is, all right. So we are done with this, which is composition. Okay. I'm gonna use it like this. Okay. Like inheritance is fundamental to OOP, composition is also fundamental to OOP. Okay. So so if we take a car object, okay, and we know that car has several parts, like car has wheels, car has steering wheel, car has many things, car has the engine, right? So we simply say car is composed of an engine. So we use an engine to make a car, right? So car is composed of an engine. So we can simply say car has an engine. But if we take inheritance, basically it's provide the is a relation, right? If we take a textbook as a class and book also as a class, we know that textbook is a book. So that means there's a is a relationship. But if we take composition, it provide has a relation. For example, car has an engine. Okay. So if we take composition versus the inheritance, uh, using composition provides the better design usually. Okay, and then I'll explain why. Okay, so if we take the inheritance, some reasons take a lot of time to load. Again, guys, I'm out of home. That's why out of town. Okay, all right. Let's do it this way. Okay. So inheritance, we use a class hierarchy, right? So there's a subclass, and then somewhere up the order there are a bunch of super classes or parent classes, right? So if we take the first parent class and then several levels of sub hierarchy, and down below we have a child class, if we make a change to that parent class, then we're going to break the code of that child class, right? So that's a good chance of that. So that means basically when we implement inheritance, there's a tight coupling between that parent class and all the other subclasses. Okay. So basically, that means basically we say the subclasses depend too tightly to the base. So if we change the base class, and obviously it can happen, right? Because software evolves, right? It may need to happen, and then when you go ahead and change the parent, and then you break the rest of the hierarchy as well. So it's not acceptable, right? So it's not acceptable. So basically, the drawback of implementing inheritance is that it create a structure that is really tightly coupled to the class hierarchy. Okay, so and changing one could break the code. That's one drawback. Also, because of the same reason, people will, they avoid, revisions and evolution. So that also not good thing, because if there's something, a problem, some problem, we should be able to fix it in a new version of the software. So now people may reluctant to do this because it's going to break the whole code base. Okay, so that's a really nightmare situation actually if you overuse inheritance. So the composition doesn't have this problem. Okay, so the other problem is hierarchy may get too complex and long, and then that complicates things.